Now, I have mentioned previously that the equations of linear graphs can be represented in a variety of forms. Now, one form we've been dealing with up until now is y-intercept form. The second form we're going to take a look at right now is known as general form. And general form looks like ax plus by is equal to c. And you'll notice I'm doing a capital C here, where previously my y-intercept form, I used a lowercase c. And that's just to really identify that that value there on its own is not my y-intercept. Now, the big difference between general form and the y-intercept form, the y-intercept form had this rearranged to have y the subject of our equation. And when we did that, there were two easy properties that we could quickly identify from our equation. We could quickly identify the slope and we could quickly identify the y-intercept. Now you can actually do the same from general form, but to investigate how we find it, let's actually rearrange this equation so it's in slope-intercept form by making y the subject of this equation. Now to do that, the very first thing I'd have to do is to subtract ax from both sides of the equation. So when I subtract ax from this side, it'll leave me with just by is equal to this capital C, subtract my ax to keep it balanced. And then to make y the subject of my equation, I would need to divide both sides of my equation by b. So when I divide the left-hand side by b, it'll just leave me with y equals. And when I divide this right-hand side by b, I'm going to divide each individual term by b. So this first term would be c over b, but I'm actually going to put that on the right just here, so you can see that I'm writing it the same way that I did previously. And when I divide this negative ax by b, this will be negative a over b multiplied by x. And because this is a positive, this will be adding on c over b. And now I've made y the subject of my equation, I've actually represented this equation in terms of a, b and c in y-intercept form, where the coefficient of my x, so this value just here, is my slope. And the constant term, so this positive c over b, is my y-intercept. So what this means is I actually have two little equations here that I can quickly use to find the slope and the y-intercept if my equation is given to me in general form, as long as I can successfully identify the values of a, b, and this capital C here. But to show you what I mean, let's take a look at a problem. Let's say that I had 2x and I subtracted 3y, and that was equal to negative 3. Well, if I can successfully identify the value of my a, the value of my b, and the value of my c, I can use that information to quickly find the slope and the y-intercept. So, the value of a is my coefficient of x. My coefficient of x here is 2. My value of b is the coefficient of y, and the coefficient of y here is negative 3. So b is equal to negative 3. And then my capital C here is the constant term that's on the other side of the equal sign. Now, it's on the other side of the equal sign, so my c value is equal to negative 3. And what I now can do is I can find the slope and the y-intercept. And I know my slope is equal to negative a divided by b. So my slope is equal to the negative of a divided by b. So if I substitute a and b in here, I can quickly find this. So it's equal to the negative of my a value of 2 divided by my b value of negative 3. Now, of course, a positive value divided by a negative value will be negative, but when I do the negative of that, it'll become a positive again. So therefore, my slope of this line is positive 2 over 3. So now I've got one piece of information that I can now use to graph this equation. But let's look for a second piece, and that's the y-intercept. So our y-intercept. Well, our y-intercept is equal to our c value divided by our b value. Now our c value here was equal to -3, and that's going to be divided by our b value, which was equal to -3. So -3 divided by -3 is +1, so therefore our y-intercept is equal to +1. And what we've now got is enough information here to quickly graph this equation. So let's have a go at that. Let's start with our y-intercept. So our y-intercept is at +1. That means that it cuts this y-axis at +1, so this point right here. And then our slope here is 2/3. Now we can consider our slope to be our rise divided by our run. So our rise here is 2, and our run here is 3. So what that means is for every 3 steps it goes across, it's going to go 2 steps up. So if we can find another coordinate, we can rule our linear line. So that means that for 3 steps that it went across, that's 1 step, 2 steps, 3 steps that it went across, it's going to go 2 steps up. So it's 1 step up, and our second step up, which is just here. So our second coordinate is right here. And what we can now do is we can rule a line between these and extend that line to represent every coordinate that exists on this linear equation. So now, as you can see, I've quickly identified the slope and the y-intercept from an equation of a linear line that was represented in general form to be able to graph that linear line. So what's important here is if you've got an equation of a linear line represented like we've got here, if you can identify the a value, the b value and the c value, you can very quickly identify the slope of that linear line as well as the y-intercept of that linear line by using these formulas.